Hello everybody and welcome back to the Kart Racer game development series. So today let's get our car actually driving around some. We're going to need some controls to actually make our car move, but the first thing that we're going to need to do is get everything set up, because the way that the Kart has been imported in Unity isn't really the best. So I'm still playing this from the last time. Okay. So before we do anything, I'm going to create a new cube. I'm going to go to 3D Object Cube, and this is going to be our ground. So I'm just going to rename that ground. You can rename it here, or you can rename it up here. Doesn't matter. Let's just do ground. And a cube specifically is being used here because I want this box collider. The box collider is actually going to prevent our object from falling through it. It's obviously not a very good size right now, so let's make it in the X direction, which is this direction. I'm going to make it 1000. And in the Z direction, I'm going to make it 1000. We don't really need to change the Y direction because that's up and down. I just need it to be thick enough for our object not to fall through it. If I were to use a plane, it's more challenging to do that, so I won't bother to do that. Okay, so I'm actually going to set this at position 0, 0, 0. And if you look carefully here, we can see that our object is above this plane. Now this white is kind of an eyesore, so we're going to make a new material for this object. I think another thing is that our directional light is set very, very bright. We were messing around with this in a previous video. So the directional light, I'm going to set this intensity down to 1. They'll get kind of our default color going on here, and maybe I will move this directional light kind of up and out of the scene. Directional lights can be positioned anywhere. They don't need to be close to the object they're illuminating because they basically cast parallel light, and it goes on forever from every direction. Okay, so I'm going to create a new material. I'm going to right click over here. I'm going to go to create this. I'm currently in the I'm in the materials folder here. I should mention that at the beginning. And I right click. I'm going to do a create material. I'm going to call the material the same thing as the object, ground. To assign the material, I can just drag it over to here, or I can drag it over to here. Okay, let's just drag it to here. It doesn't look any different because the default color is, again, going to be white, which, based on our lighting, is not going to be that bright. So if I click on the ground object down here, I can then adjust the color to whatever color I want. However, I don't actually want that to be a solid color. Instead, what I want to do is I want to click on this selector here. If you drag a texture into here, you can actually assign a texture to this object. But I don't have any textures at the moment that I want to use. We're eventually going to create a track. It's going to look like the road. But for right now, anyway, just so that when we're testing out our car, if the car moves, I want to be able to see that it's moving. So I'm going to click on this icon right here, and that'll allow me to select one of the built-in graphics that are already currently available in Unity. These are all default. So we have a checkerboard here, and we also have a checkerboard here. I'm going to pick this one. You can see it assigns a checkerboard, but it's huge, so that's actually okay. So in order to make it less huge, what I'm going to do is change this to tiling 100 by 100. And you can see now that it's going to be easier for us to tell whether or not our car's moving when the time comes. So that's basically it. I'm also going to be, because we talked about collisions, if our car falls, I want it to not fall through this ground object. So collisions generally happen. Every single object in the scene has to be checked against every other object. And so that's actually like a very, very CPU or GPU intensive operation. So what I'm going to do is I'm going to specifically put different kinds of objects on different layers, and then I can turn off collisions on certain layers if I know they're never going to happen, or I don't care if those kinds of collisions happen. So I'm going to create a new layer called ground. So if you go to here to add layer, it's going to pop up with a new list of layers that I can create. There's some built-in ones you can see, but starting from user layer 8 here, I have a whole bunch of options for my own. So I'm going to create a layer called ground. And while I'm at it, I'm also going to create 2 more layers. One, I'm going to create a layer for my car wheel. So I'm going to say car underscore wheel. And I'm also going to create one for the rest of my car. So if my car flips over, or the wheels have suspension, the car scrapes against the ground, I'm going to have car underscore non-wheel. So those are the 3 layers that I've got now. So now if I select this ground, Notice that I'm still in the default layer. I have to select the ground layer now. Okay. And then for our cart, what I'm going to do is pick that, and I'm going to select car non-wheel. And we'll actually just change the wheels when the time comes. Okay, so we'll set that to non-wheel. It asks, because there are child objects, it says, do you want the children to be also set to car non-wheel? I'm going to pick yes for now, and we'll eventually make some changes to some of the children. Okay, so there we go. So far, so good. So the next thing I'm going to do is on my cart as a whole, I'm actually going to remove this auto rotator script. We don't want that. So I'm just going to say remove component. I am going to add a new component. There's a bunch of built-in components in Unity that are very helpful. So the first one I'm going to add is called a rigid body. And a rigid body is basically a physics simulator. So this is going to allow this object to start falling. So now that I've added this object, this car will fall. But it won't crash into the ground. I need another thing for that. I'm going to need some kind of a collider for that. So the rigid body and the collider kind of work together to implement the physics system. So the rigid body is going to keep track of the gravity and a few other effects. And the box collider is going to make sure that objects don't collide. So Unity also has a 2D mode, so make sure that you pick the box collider, not the box collider 2D. You do not want to use 3D and 2D physics together. They don't look good that way. They don't work. Okay, so that creates a box collider. It doesn't know how big the box collider should be, so rather than scale up my object, which is going to scale up my entire cart and the little box collider within it, I'm going to click this Edit Collider button right here. Okay, and I'm just going to adjust these, so you can have these little handles when it's in edit mode, these little handles that you can expand out, and it's kind of hard to tell in 3D exactly what this is looking like, so I'm just going to drag this out from what looks like an okay view from my perspective, and then let's view it from different angles. Okay, so from the side, this actually looks pretty good on the bottom. Okay, and so I'm just going to drag this up just a bit. I'm going to drag the top up so that it actually doesn't need to be perfect. And I think I'm going to be okay if this car were to flip over and a little piece of it were in the ground. I would actually be okay with that. You can do something other than a box collider if you want to get something more precise. But a box collider is going to be very efficient. So it's a really good strategy if you just want to make sure that's as simple as possible, because a box collider and a sphere collider, these are extremely efficient. So if I have two boxes, for example, I can determine if they collide really efficiently. So the number of objects in my scene is not going to slow me down to a slower frame rate quite as much as if I use something like a mesh collider, which will follow all the contours of our object. Now this is a low poly model, so the mesh wouldn't be that complicated, but it still actually makes a difference. Okay, so let's actually look from the top view now. Well, maybe adjust this a tiny bit more on the front and back. And then we'll look from the top view by clicking on the Y here. And now I'm just going to adjust this so that it's a little bit more precise. This doesn't matter too much, but a little bit more precise would be good. Now, one of the important things, I'm going to view this from the side to talk about this. One of the most important things about this, this is not quite right. In the back. There we go. So viewing this from the side, one of the most important things is make sure that your box doesn't go all the way down to the ground. All the way down to the ground would actually be very wrong, because basically this object should not be dragging against the ground. I don't want that to happen. Right now, if I turn on the game, that's what's going to happen, because these wheels don't really have a collider, and so they're actually going to sink through the ground. Let's actually test that out to see. Okay, so you can kind of see this is a little bit weird. I'm going to go to scene view for this, and I will view it from the top. So you can see that the box collider is sitting right on the box collider of the ground. So if I select the box collider of the ground, I select the cart, you can see that the box collider, this isn't the gizmo for the box collider, is sitting right on top of the box collider for the box of the ground. And so that's okay. That's going to prevent us, imagine we have springs on our wheels and our springs are really loose. Then our car may go down, hit the ground, and make sure that it's not going to go into the ground. And similarly, if we crash head-on or if we flip over or whatever, the box collider will keep our object looking reasonable so it's not going into the geometry too much. Okay. So that's basically the start. Again, it doesn't need to be perfect for our relatively low poly game. If you want to, instead of adding one box collider, you can add multiple box colliders. So for example, from the side view here, oops, the side view is X, you might create a box right here, which would match this geometry a little bit more perfectly. Maybe a smaller box here, maybe a larger box here, another larger box, slightly smaller than that one box here. And so on. Those might be really helpful for you to get more precise geometry. And because they're boxes, even though there might be something like 10 or 12 of them, it's still going to be more efficient than if we were checking against the mesh collider, because the mesh collider has to check every single face of the object. Sorry about my squeaky chair. So that's still going to be more efficient. But in this case, I'm happy with just a single box. I don't need this to be super precise. But if I back up against a wall, I kind of want it to, to stop here. And if I'm going forward into a wall, I kind of want it to stop here, maybe even all the way to the front. That's fine. If my car flips over, then I've got other things to worry about, whether my geometry clips through the ground or not. Okay, so now the real colliders for this car, the ones that are going to be used all the time, are going to be part of our wheels. So the next thing that we're going to do, oh, by the way, I should actually change the cart so that it has a mass. So right now the masses are all in metric units, so I'm going to set this thing to 100 kilos, which generally is probably fine, but I just don't want to forget to do that. All right, so the next thing we're going to do is we're going to reorganize all of this. So it won't allow me to change this object unless I unpack it. So I'm going to go in, I'm going to right click on this object here. I'm going to go unpack prefab. And you can see that it's actually not a prefab anymore. So this is a separate object. I still have my basic card over here, but it's not really a part of it anymore. Alright, so one of the things that you can do in Unity is you can create an empty object, and it kind of acts like a folder. It's a little bit more than that, but it also kind of acts like a folder. So what I'm going to do is I'm going to right click on this object here, and I'm going to pick Create Empty. And an empty object has a transform. Every single game object in Unity has a transform. I'm going to leave this game object at 0, 0, 0. It's not going to be rotated, it's not going to be translated, and it's not going to be scaled. So all these values are default. But this is going to be sort of like a place where I can put everything that's closely related. So first I'm going to create this empty game object called wheel geometry. And then I'm going to take the 3 wheels right here, and I'm going to put those, whoops, we have the steering wheel, I didn't mean that one, the right wheel, the right front wheel, and also I'm going to control click these ones. So just control click to select all 4 of these wheels, and I'm going to drag those into wheel geometry. Okay, actually that's not perfect right now. If you kind of look at this really carefully, when we were modeling this, I scaled things down so you can see that I have this kind of bizarre scale that's happening here. And I also have some rotations and some translations and so on. Each of the objects is going to have a slightly different translation. For example, the left front wheel has a position, and that's because I think that was the first wheel that I created, and then I moved it back, and so I had the left front wheel as well, and that got shifted in a little bit, and then the wheels on the other side were actually shifted over even more. Okay, so that'd be these ones. Okay, so that's those different positions, and we also scrolled up and down, moved them up and down because the back wheels are a little bit larger. So anyway, the problem with this is going to complicate my scripting a little later. So we're not doing scripting today, but we are eventually going to do some scripting on this object, and I kind of want these wheels to be as simple as possible. So here's what I'm going to do. I'm going to create 4 empties inside this wheel geometry. So I'm going to go create empty, and I'm going to call that left front, and then I'm going to do Control D to duplicate, and I'm going to duplicate that 4 times. So we're going to say left front, I'm going to say right front, I'm going to say left rear, and I'm going to say right rear. Now these are just empty objects. You can see they're in the default object, the default transform. So they're all kind of in the middle of our car, and that's not actually what I want. So what I'm going to do is I'm going to click on left front wheel, and this has the actual positions and all that stuff for that wheel. And I'm going to click this little three-dot menu here. I'm going to say copy component. Okay, that'll copy all the parameters inside this transform. Then I'm going to go to left front, the empty object, and I'm going to go to paste component values. And you'll see that now it's centered in the same position, but it also has all the same rotation and scale. So I'm going to do that for each object. So left rear wheel, copy component, go to left rear, paste component values. You can see now that that's there. Then I'm going to go to right front wheel, and I'm going to go to copy component, click on right front, paste component values. And finally, I think we have right rear wheel. It's going to be copy component, click on right rear, and do paste component values. Let me just make sure I didn't miss any of those. So I've got the left front, the right front, the left rear, and the right rear. Okay. And now what you'll see is if I drag the left front wheel into the left front as a child, you can see the left front wheel now has an empty transform, which makes it really easy for me to make some changes to it programmatically. I can do the same thing for the right front wheel, drag it into the right front. If you drag the wrong one in the wrong one, then it's not going to match up. It's just that right front already has this translations and these rotations and these scales. So since both objects have the exact same scale, relative to its parent, this right front wheel doesn't need to be translated or rotated or scaled because the parent is already rotated that exact same amount. So I'm just going to drag all four of these objects into the corresponding empties, and that's going to make our job pretty easy. So you'll see that all four of the wheels now has a default transform. There and there. So there we go. So that's the idea. And what we're eventually going to want to do, and I think I sort of demonstrated this to you before, is I'm going to want to look at the local coordinate system here, and we're currently looking at the left wheel. So I'm just going to maybe look at this from a slightly different angle so we can see a little better. Maybe scroll in a bit. There we go. Oh, not scroll in so that it clips the geometry. There we go. And you can see that our axis coming out of here is blue, which means that's the z-axis. So if I want to rotate this thing on the z-axis using the local, then that'll rotate the object this way. So if the car is moving forward, I want to rotate the object this way. Okay? And because, as it turns out, in this case, I'll turn this into global mode, it's a different axis in global mode. But so in local transform, I would rotate it on the z-axis. In global transform, I would rotate on the x-axis. Doesn't really matter which one I do. However, if the car starts to flip around, I still want the wheel to kind of rotate relative to its axle. So anyway, in this case, let's turn this on. I'm going to do a Z rotation here so you can see what that looks like. That's a Z rotation. And the rest of the object keeps its default transform, which is really quite simple. I can also do a turn. So for example, if I want to do an X rotation here, again, that's going to steer our object. And again, that's just a local transform. So it's really simple. Okay, so anyway, that's going to make our job a little easier when we're scripting. I also have to create a bunch of colliders. Now I can actually just select this wheel, go down here and create another collider for it, just like we did. There aren't colliders that look exactly like these wheels, but there are capsule colliders, which are sort of like, look like a pill shape, and there are also sphere colliders, both of which are, you know, roughly accurate. But I don't actually want to put the wheels and the geometry together because the Unity documentation specifically recommends against it. This is just sort of the look that we want to show our users that we have wheels. These are not actually going to be causing friction against the ground. So in reality, what we want to do is we want to create a completely separate object. So just to make things really easy, so I can be a little bit lazy here, I'm going to select this wheel geometry. I'm going to do Control-D to duplicate it. So I'll create another wheel geometry, and you'll see that we have all these same children here. But I'm going to rename this wheel colliders. All right. Now, actually, we've got 2 copies of each wheel's geometry here, but I don't actually need the geometry in the wheel colliders. So make sure that you're in wheel colliders, not wheel geometry. I'm just going to go in and I'm going to delete these 4 child objects here. So I'm going to delete the left front wheel, delete the right front wheel, delete the left rear wheel, and delete the right rear wheel. But the advantage of this is that I have all of these objects positioned in exactly the right center coordinate, and now I can just go through adding a wheel collider to each one. Okay, so actually one of the cool things that you can do in Unity is you can shift select all of these and you can add the same component to all of them. You see that it kind of puts this line through things because these all have different positions here, different positions, rotations, and scales. So you can't set it, but if I actually were to type in a value, it would overwrite them all to have the same X value. For example, if I type that in here, and that would not be good because it ended up putting the wheel colliders in the same spot, in the same X coordinate anyway. But I can add a component, so I'm going to go in here and add a wheel. So you can see we have a wheel collider. I can add that in. And then we've got some pretty decent defaults here. So we have the default set to 20. That sounds good. The radius we're going to have to set on a per wheel basis, but I'm going to set some of these. I'm going to set some of these specifically to all of the wheels together, so that'll save us a little bit of trouble. So for example, for now, we're not going to have suspension at all. So I'm just going to, I'm going to leave the radius, I'm going to set the suspension distance to 0. And what that's going to do is means that there's not going to be any play up and down for this wheel. It's just basically land like a rock as this car falls down. Okay? And based on the radius is where it's going to stop. For a little bit later, I'm going to put in some parameters for the suspension. So I'm going to set this suspension value to 100,000. I believe these are in newtons. And then also, so this is the spring constant, or the spring force, and this is the damping force. So this is going to be 10,000, I think. Yeah, 10,000. Okay, and we'll adjust some of these parameters a little later, but these aren't going to be used right now because right now we're saying suspension distance 0, so don't allow any suspension to happen. Anyhow, in order to make this work, before I set the suspension distance, let me actually change it back on this one, for example. You can see it has this little projection going down. This is basically looking for the ground so that we can see if there's an intersection with the ground. If that intersection is less than our radius, then it's going to activate the suspension. Since I have suspension distance set to 0, then it doesn't bother to check that, but if I have suspension distance set to something, it's going to check to see exactly where, how much up and down should there be in the suspension. It's going to use this kind of ray cast down here to see where the wheel intersects. Sorry, if I cast a ray down here, where does it intersect with the ground? If it intersects with the ground closer than the radius, which means it's like above here, then we're going to have to shift our wheels up and stuff. It's not going to shift the geometry, but it will actually make the body of the object sink down a little bit. That's it for right now, setting that to 0. So no reason to do anything special there. Okay, so now we're going to have to set the parameters for each of these. So for the left front alone, I'm going to set the radius. Let's actually get rid of that gizmo there. So for the left front, I'm going to set the radius to 1.5. And this is the left front. Okay. And we can set this radius, again, we can drag it. I'm not sure why it's not actually showing up there. Oh, I remember why. Because this collider right here doesn't want to have any scale. So I'm actually going to select all of these. I'm going to set their scale to 111. Okay, there we go. So you can see now, we can see the radius. So I'm going to select the left front. And we're going to pick, sorry, actually for our front one, I want 1.5. Okay. Now you can actually see that that's a slight bit bigger. Now I could get really precise with it, 1.35 for example. But a little bit bigger than the wheel actually isn't the worst idea. I don't want too much, because then it'll look like our car is hovering off the ground. But let's make it 1.4. Alright, and then I'm going to do right front. I'm going to set that one to 1.4 as well. See, that shows up there. And for the rear ones, I'm going to use 1.75. There we go. Again, it's just a little bit bigger than the wheel. That's okay. And then for the right wheel, right rear, can't really see it that well, but let's go over here. 1.75 also. Alright, so this is actually a pretty good start. So if we click play, let's watch what happens here. You can see, let's go in our scene view here. You can see that the car no longer falls onto its body collider, it falls onto the wheel colliders. So you can see that wheel collider is exactly intersecting with the ground. It's a circle, so the kinds of calculations that we're doing are really, really simple. There's a bunch of settings in here for the wheel collider that we're probably going to have to mess with a little bit later, so we can have some slipping and sliding as we go into corners. But for right now, these settings are going to be just fine. So we've got these 4 colliders. Let's take a quick peek at them all. And they're all leaning on the ground. Okay, so if you remember when we were doing the model, I specifically tried to make these wheels so that the bottoms were approximately equal. I didn't go out of my way to make sure that they were absolutely equal, and that's because even if this one was a little bit bigger, that would just mean that the body of the car would lean forward. Maybe aerodynamically that's not a good idea, but it actually seems like it's not such a big deal for right now. Okay, so we didn't accomplish too much today, but I'm going to do one more video after this one and kind of this little mini part where we're going to go in and start working on some of the code. So hopefully you're ready for some basic coding. And then what we're going to do is we're going to map some of the keyboard and gamepad controls to changes to some of the parameters for our wheel colliders down here. And also, in order to make this look nice, we're also going to rotate the wheel geometry as well, so that when we're steering, we're going to turn our steering wheel, we're going to turn our 2 wheels that are going to steer our car, and as the car rotates forward, I'm also going to rotate the geometry of the wheel so that we can start getting that working as well. Okay, so anyway, that's good for now. Again, if you want to post the results of your work, please do so on Twitter. But anyway, expect the next video in the next couple of days, so I hope to see you back then.